Okay, this is Mr. Green, and I'm recording another in my sessions of lessons that I'm wanting you to watch before you get into the topics too deeply. For those of you in AP Stats that have been wondering, well, when are we actually going to do anything with numbers? This is a math course after all. Well, this is where we start doing a little bit with numbers. We've been talking about how do we describe data and how do we describe graphs, and we looked at a couple of things of that nature. But what we're going to do now is we're actually going to try to use some numerical methods for describing data. Okay? So what we're looking at here is a situation. It says traumatic knee dislocation often requires surgery to repair ruptured ligaments. One measure of recovery is the range of motion, measured by angle formed when starting with the leg straight. The knee is bent as far as possible. The article reconstruction of the anterior and posterior cruciate ligament after knee dislocation reported the following post-surgical knee range of motion for a sample of 13 patients. And you can see they've just have recorded the angles here. I'm just going to point to them here. 42, 137, 133, etc. Well, one of the measures that we can use to say whether this was interesting or not was to just add up all these angles, okay, and then divide by the 13 angles that we have, okay? If we add them all up and divide by 13, what we wind up with is a number 130.38. You notice how it's got this X with a bar over it. That is the word for the mean. M-E-A-N, mean. It's kind of like the average of all the numbers. Okay? Well, matter of fact, it is. In another words, way of saying it is called the average. But as the mean is what we're looking there. We call it X bar because we're going to, X usually has other meanings in other places. But if you ranked the numbers from lowest to highest and then found the median number is 133. Well, here's a question for you. Why is the X bar the mean and the median different numbers? If the median's the middle number and the X bar is the average of the numbers, what does that tell you when the median and the mean aren't at the same place? Well, it might mean that, the numbers are actually moved a little bit one way or the other, right? And that's what we're talking about at this point. Here's another one. The pedaling, P-E-D-A-L-I-N-E, paddling technique of elite endurance cyclists reported the accompanying data for a single leg power at a high workload. Gee, I have no idea what this information is, but it's the pedaling technique of elite endurance cyclists. So they're looking at some numbers here, 160s, 180s, 190s, 200s, 244. Looks like they've ranked them in order here. The median number fits between 187 and 191 because there's an even number of items here. And so what they had to do is add 187 and 191 together and divide by 2, and that gives them a median of 189. Yet my X bar is 192. Let's look at these two in comparison to each other, okay? This one, the X bar was lower than the median. In this one, the X bar is greater than the median. What is that telling you? It must mean shifted the other way, right? Well, that's interesting. But you know what? Notice this number way over here, 244. There's a huge gap from 211 to 244. That huge gap is sometimes called an outlier. It affects this number tremendously, but doesn't affect this one hardly at all. Okay? So let's look. If we took that 244 out and found the X bar, notice what happens. 189.71, and the median's 189. It means that the mean is not resistant to outliers. What does not resistant mean? Well, if it's resistant, that means it wouldn't be affected by it. but the mean is non-resistant, meaning that it is affected by outliers. Outliers are those items, those numbers that we get that are way outside of where we would normally be looking at them. Okay? So you just have to be aware that's what we're talking about when we're talking about the outliers. Now, trimmed mean, if I look at the average of these two numbers, 192 and 189, the average of those two numbers is 191. So what I'm looking at here when I'm talking about a trimmed mean is I'm looking at the average of the X bar and the X bar without the outliner, and that's what we get the trimmed mean as, okay? So I'm giving you some numbers there and some terminology that you're going to see when you're looking at the AP test, okay? Let's look at this one. The ages measured by last birthday of the employees of Dewey, Cheatham, and Howe are listed below. Well, they just listed off a bunch of ages there. The X bar age is 35.33 years old. The median is 35.5. What can we do? Well, there are several different ways we could display this. I want you to notice, what's this one over here? This is called a stem and leaf plot, okay? What they did is they wrote down the 2, wrote it here as a stem, and then they wrote down any numbers that had 2s in them. They started with a 2. They wrote down the 1's digit number off here as a leaf. And they wrote down the 3 30s here, and any numbers that were in the 30s, they wrote their 1's digit over here. And the 40s they wrote here. You can tell by just looking at this, most of the people are in their 30s. Yeah? That's what a stem and leaf is really good at doing. You can look at it and see you've almost got a histogram of their ages just by looking at that little diagram right there. If you look at this one, you say, if we look at our higher 40s and our lower 40s and our higher 30s and our lower 30s and our higher 20s and our lower 20s, we still get these higher 30s as the highest numbers here. This is the histogram is the highest ones here. But you know what? It's a little bit flatter of a graph, isn't it? Might tell you a little bit more. This is one technique that is used to divide things up. Now I want you to notice down here at the bottom, we got the median right here at 35.3. If we took 25% of the numbers, half of the median between here and here, half of the numbers would give us Q1. It's called quartile 1. That means 25% of the numbers are over here, 25% of the numbers are in here. 25% of the numbers are in here, 25% of the numbers are in here. That's what this Q1 and Q3 are. Okay? Finding them, well, you can tell they ranked the numbers here, they found the median, then they found the number halfway between here and there, and that's the median there. So we got 3, 5 numbers here, 3, 6 numbers here, 3, 6 numbers here, 3, 6 numbers there. I said 5. There's 6, 6, 6, 6, and 6. Yeah. Sorry, I've got something in the way because I've got a little keyboard thing there. Okay. So what are we talking about? We found the quartiles. Okay. What can we do with those quartiles? That's a different story. What we're looking at in this one, it says the Consumer Reports April 2007 edition is the following gas mileage is reported in mixed driving for the following 5 brands of Subarus. So we got a Subaru B9 Tabeka, we got a Forester, we got an Impreza, we got a Legacy, we got an Outback. Basically, it's just reporting miles per gallon, right? Well, if you added up all of these and divided by 5, you're going to get an average, a mean, an X bar of 19.6. The median is 19. Well, you know what? Just knowing what that median is isn't really enough to help us understand these numbers very good. Sometimes we want to know, how far do they differ? I mean, is it like this one over here, flat like this, or is it really steep like this one? So we want to know what the variance is, the average of the differences. So what we're going to do is we're going to use a little bit of of Greek terminology here. See this little symbol here? This is called a sigma, or a summation sign, okay? And what we're going to do is we're going to take xi minus x bar. Well, what is xi? Xi is each one of these different numbers, 16, 22, 23, 18, 19. And I'm going to subtract the x bar from it, xi minus x bar. And I'm going to square that and add them up. Okay? Let's try that real quickly here. So I'm going to take 16 minus 19.6, take the difference, and I'm going to square it. 22 minus 19.6, take the difference, and then I'm going to square it. 23 minus 19.6, take the difference, square it. Okay? And I'm going to take all of these and add them up, and I get 33.2. Now, going back to that formula real quickly, you notice out here in the front it's got 1 over n minus 1. Well, there are 5 items here. So n is 5, minus 1 is 4, so I'm going to take 1/4 of that 33.2. So when I multiply it times 1/4, 33.2, I get this number right here, 8.3. You notice how I listed that as s squared, because that's my variance squared. And standard deviation is the square root of the variance. So what I'm going to do is I'm going to take the square root of that, and I'm going to get 2.88. Now, we're all talking about miles per gallon here. So roughly speaking, the standard deviation of 2.88 miles per gallon measures a typical or average distance between the individual gas mileage ratings and the mean gas mileage rating for a Subaru, meaning that typically the cars have that 2.88 miles per gallon difference from the mean. That's important to know. That is a good measure of variance. Now, compare that with a Toyota Prius, which has an X bar, an average of 23.66, and has a variance of a standard deviation of 10.29 miles per gallon. What is the difference between these? Okay? You're talking about 16.9 with 288 and 23.6 with a 10.29. It means that this one, the Toyota Prius, is a much flatter graph, even though the X bar is higher. And this one up here, the Subaru, is a little bit steeper graph because they're a little bit tighter bunched around that 16 point number. That's what these are all about. That's these numbers, the mean, the median, the standard deviation. Those are the numbers that give you how you can verbally, how you can tell with numbers what types of data we're looking at, what the data is doing, okay? So hopefully this helps with this lesson. There will be a few more in this series, and I will talk to you next time.